Today we're going to learn how to find the area of a parallelogram, which is what we got introduced to yesterday with those bases and heights. So we are going to just review a couple characteristics about parallelograms. So remember, a parallelogram is a quadrilateral, meaning it has four sides. It has two pairs of parallel sides. Opposite sides have the same length, just like in a rectangle. And today we're finding area, so let's just remember that area is the amount of space inside an object. Okay. I want you to take a minute and pause the video, and I want you to kind of think about how we could find the area of the shape without counting the boxes. We did some of this yesterday. It had to do with cutting it up and moving pieces. So pause the video, go ahead and try to do that on your own to see if you could come up with the area of this shape right here. Right? So if you're with me now, you should have already tried to cut this up and move pieces over, and you were just checking your work. So the way I would cut it is I like to cut it at the corner. You could cut it at any single one of these lines that are going down, but I like to cut it at the corner. It's just the smallest piece that you can take off and then shift it over, and that would fill in right here. So if I were to color that in, that's what I'm talking about, and I'm moving it over so that it's right here. I can then count for my base and my height. So I'm going to count for the top since that distance didn't really change, since I can't actually physically move that triangle over on this screen. So I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes is the base. And then the height, I'm counting that side. 1, 2, 3, 4, 5, 6, 7, 8. So I would have a height of 8 and a base of 12. So I would do 12 times 8. Now I want you to think about when we move that triangle over, did it change the amount of area that we have? No, right? Because we've been talking about when we move pieces over, the area does not change. So the way we find the area of a parallelogram is by doing just the base times the height. But we're going to learn how to do that without having to move pieces over because that takes too long. So the formula for finding the area of a parallelogram is base. And we're going to use a star for times because eventually we're going to have x's in our math problem. So base times height. Okay, to shorten that up, we just say A equals B times H, where the base is one of the sides of the parallelogram. We talked about that yesterday. And the height is the straight distance between that base and the one across from it. Okay, it has to be at a 90-degree angle, it has to touch the base, and it has to be across from it. Remember that height can either be written inside or outside of a shape. So right down here, we're just reviewing finding the base and the height. I think it's easiest to find the height first. That's that dotted line with the 90-degree angle that's touching the base and going straight across. So here in this blue parallelogram, our height is going to be 8. Once we know our height, we can draw over it to decide what side of that parallelogram it's touching. Well, it's touching the top and the bottom. So the base that we would be using for this problem is 16. Okay. Number 2 is tricky because it's turned. So if you want to turn your paper so that it's facing a normal way that we would, you can, or you can just leave it like this. First, we're going to look for that height. It's almost always a dotted line that has a 90-degree angle and is showing the distance from one side across from it. So our height right here is going to be 4. And that 4 is going to touch our bases. And again, it's written outside, but it could have just as easily been written in here. So it does touch those bases. And our base would also be 4. All right. Flip it over. Let's start practicing to find the area of a parallelogram. When we find the area of a parallelogram, we have to show our work. So we write our formula, A equals B times H. And when you're doing multiply, you can just put B and H next to each other, or you can put that star in between them to show multiplication. That is fine as well. Okay. Then we use substitution. So then we're going to plug in what is the number for the base, what is the number for the height, and then we'll multiply and write our answer with the correct label. When we are finding area, it's going to be units squared. So if it's centimeters, it's going to be centimeters squared. If it's feet, it's going to be feet squared, and so on. So it's always going to have that little 2 up next to it. All right, so number 3, let's start with our formula. So A equals B times H. Then let's do our substitution. Let's plug in our numbers for our base and our numbers for our height. Well, our height is 7. I can see that because it's that straight line going across. And the side of the parallelogram that 7 is touching or connecting is the 9. So I know my base is going to be 9 and my height is going to be 7. Then I just multiply 9 times 7. That area is 63 centimeters squared. And that's it. That's how we find the area of a parallelogram, just base times height. All right, so in number 4 over here, we have our formula. A equals B times H. A equals, in our base and our height, well, our height is 8 because it's connecting it, going across from both sides. And the sides that it's connecting are the left and right sides. So our base is 12 and our height is 8. If we have a multiplication chart, we can check what 12 times 8 is. If not, we can always pull that to the side and just multiply it out real quick. 8 times 2 is 16. 8 times 1 is 8, plus 1 is 9. So our area over here would be 96 feet squared. It's bothering me that that wasn't touching. Sorry. Okay, last but not least, we're going to have some shapes like this. And we did some of these the other day where there's going to be a chunk missing and we only want what's shaded in. So what the steps we're going to take for this is we're going to find the area of the outside shape. And I'm just going to put out because I don't have enough space. So find the area of that big outside shape. Then we're going to find the area of that little inside shape. I'm just going to put in instead of inside. And then if we only want what's in yellow for this example, I want you to think to yourself, what are we going to do with those two areas? Are we going to add them together? Are we adding an area or are we taking out area? We're taking out area. And when we take out, that is subtraction. Okay, so let's start with our big parallelogram. We've got a height of 5 and a base of 7. So we would do B times H. 5. Oops, that's not what I wanted to do. 1 second. Okay, there we go. 5 times 7. That's a B, that's an H. Sorry. And that is equal to 35 feet squared. Now I have to find the area of my small little rectangle in there. I'm going to erase some of these lines because I can't really read that. So I've got 3 times 1 because it's just a rectangle. So I'd have base times height. 3 times 1 is 3 feet squared. Then I would subtract 3 feet and 35 feet. And I would get a final answer of 32 feet squared. Okay. Same thing for this next one. So if you're feeling ready, I want you to pause this video, try this next one on your own, and then resume your video to check your work. So we'd first start by finding the area of that big one. So B times H. The height of that big parallelogram is 8. Our base that connects the top and the bottom would be 15. 15 times 8 is not a common factor, so I'm going to pull that to the side. 15 times 8 and multiply it out. 5 times 8 is 40. 8 times 1 is 8 plus 4 is 12. So this is going to be 120 millimeters squared. Then we find our little guy inside. That's going to be 6 times 3, so base times height. 6 times 3, 18 millimeters squared. Last step, I subtract those. 120 minus 18. Well, I'm going to drop off the 100 and just do some mental math. 20 minus 18 I know is 2, and then I have 100 left, so I've got 102 millimeters squared for my final answer here. Okay, so that is how we find the area of a parallelogram. I want to show you one more thing back on this front side. So flip your paper back over to the front real quick because you're going to have examples like this on your homework, if not today, but definitely tomorrow. We're going to be given shapes that have boxes, and for a parallelogram, it's tricky, but you are counting every single space as one that has a line on it. So this is one box. Even though only 3/4 of the box is like full, that is still one full box as a length of the base. So when we count the base on a grid, this parallelogram would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 as the base. Then when we count that height, we do not count the side length. Remember, a height is straight up and down. So you can pick any one of these lines inside, and you're counting how many boxes straight up that it goes. So that would be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if you're given a shape that does not have any numbers on it, you have to count for the base and the height and just make sure you're counting those full boxes. Even though that box is not completely full with the shape, that line is a full box. And we're just counting how long is that line, and that line is 12 boxes. Okay, and that is how we find the area of a parallelogram.